All right, here are solutions to perfect problem 5. In this problem, basically what we're asked to do is find the derivatives of these three guys here using the chain rule. We've proved these in the past using other rules, the product and the quotient rules, and it was kind of a pain. Using the chain rule would be quite a bit easier. So what we'll do here is first we're going to find the derivative of secant of x. And what we're going to note is that secant of x is the same as 1 over cosine of x. And another way to think about that is it's the derivative of, cosine of x raised up to the -1 power. So if you think about secant in these terms, it's a little bit easier to figure out because now we can use the chain rule. So it would be -1 times cosine of x raised up to the -2 times the derivative of cosine, and the derivative of cosine is negative sine. I guess I'll write the derivative of cosine. So we have negative sign here and I'll write it all out. -1 cosine to the -2x times negative sine of x. The negatives cancel each other out, and what we're left here is sine of x over cosine squared of x, which is sine of x over cosine of x, times 1 over cosine of x. Sine over cosine is tangent. 1 over cosine is secant. So there we go. There's the same thing using the chain rule. Second one, really the same idea. Now it's derivative of cosecant. Okay. The derivative of cosecant is the same as the derivative of sine of x raised up to the -1 power. And we can find this derivative using the chain rule. It's -1 times sine of x raised up to the -2 times the derivative of sine of x. And so derivative of sine of x is cosine. So what we have here is negative cosine of x over sine squared of x, which is negative, 1 over sine times cosine over sine, which is equal to negative cosecant of x times cotangent of x. Okay, which is what we got up here. Good. This last one, derivative of 2e to the 2x plus 1. What we can first do is pull the 2 out in front and say this is 2 times the derivative of e to the 2x plus 1. And we can now take advantage of the chain rule. We could say this is 2 times the derivative of e to the anything is e to the anything. But we have to use the chain rule here and multiply this by the derivative of 2x plus 1. So we have 2 times e to the 2x plus 1 times 2. We got 4e to the 2x plus 1 as our derivative. So here's 3 problems we've seen before, done easier, quicker, I don't know, differently, using the chain rule. So I guess that's the end of this perfect problem.